All right, ladies and gentlemen, so I realized that the notes that were given on the unit circle are a little bit brief. So I'm going to swap to Sharpie. I wanted to talk a little bit about this and kind of shed some light, because it seems a little bit weird at first, but it's actually pretty useful. So the idea is that if we have a circle, and we make that a circle with radius 1, or 1 unit, and unit circle, then some useful stuff happens when we look at points that are around the outside of the circle. So let's say that we draw ourselves this angle right here. It doesn't really matter. We're going to call this theta. So if I have this theta angle, and it's in standard position, right, because this is 0, 0 here at the center. So I'm standard position, I'm opening up, no big deal. Then the coordinates of this point end up being something useful. And if we draw ourselves a little right triangle, what we end up with is this really particular right triangle that has a hypotenuse of 1. Because the radius is 1, and that radius is the same all the way around. So hypotenuse is 1. Okay. If I go ahead and fill in the rest of my stuff, label things like trig style, this is angle straight across is the opposite, which means this, right, to here is the adjacent side. And I don't know how long they are, but that's okay. If I start to describe the sine and the cosine of this angle using the things that I have some useful things that show up. The adjacent side, you might notice this distance lined up with this point is equal to the x coordinate of that point. If this is 0, 0, the x distance is here. So the adjacent side is equal to the x coordinate. And the opposite side, from 0 up, this is the height of this point here. This is the y coordinate of that point. So we've set everything up, and then the magic happens, right? The rabbit gets pulled out of the hat. So if I write this stuff, it turns out that the sine of that angle, opposite over hypotenuse, right? So the opposite over hypotenuse, but the opposite is whatever the y value is, and the hypotenuse is just 1. So that means that the sine of that angle is equal to the actual y value of this point. And likewise, I can do the same thing with cosine. Right? The cosine of that angle is the adjacent over the hypotenuse, which is the x coordinate over 1, which is just the x coordinate of that point. So what does this tell me? Well, it tells me that if I want to know the sine of some particular angle, then all I need to do is grab my radius, open it up to that angle, and read what the x and y coordinates of that point are. The advantage here is that now, because we're working on a circle, all of a sudden I have the ability to make some sense out of what, say, the sine of 130 is. Right? Before, the sine and the cosine and the tangent all revolved around right triangles, and it didn't make a lot of sense for us to talk about what if this angle is bigger than 90, because we can't have more than 180 degrees in a triangle, so it doesn't work. But using the unit circle, I can now kind of do some trickery and at least extend the pattern for sine and cosine for angles beyond 90, as well as for negative angles. Can work it both ways. And we'll look at some more specific examples as things go on, but the moral of the story is that this point here has coordinates of cosine theta, sine theta. That's the unit circle in a nutshell. I'm going to go into a little bit more detail in the next video, but for now, that's what's up with the unit circle.